we're gonna run some code on a computer cluster, which we will also set up for free on Google Cloud. To set up a cluster, I'll be using the software called HTCondor. What I will run is an example from Google Cloud Platform. It's on GitHub. It computes prime numbers. Now, this is how the example works. Primes 100,000. It takes a while. It found 9,500 prime numbers in 1.2 seconds. So it's a computation that takes a while. Let's say you want to run 100 copies of that, maybe with different parameters, on a cluster. So how do you do that? You can have a free 1-year trial of Google Cloud Platform, and we're going to set up an instance, a new machine that we'll call master. Now I will leave all the configuration default. It will be running Debian 9. The only exception, I will allow HTTP and HTTPS traffic, and I'm going to create that machine. Now there are several ways to connect to that machine. Obviously we're not using the graphical interface. You can connect through a browser, or you can connect through SSH, but it takes a while to set up proper authentication. You need to create the key, add it through the Google interface. So Google, they actually created their own tool, Gcloud Compute SSH master. There you go. So I'm in that machine. I can take a look. It runs Linux 4.9 kernel. I can check that it does indeed have 3.7 gigs of memory, and so on. You can look at the CPUs that it has. So it runs Debian, so you can install whatever packages you'd like. We are going to install HTCondor, which is not in any standard repository. So first we're gonna add a new repository, and also I'm going to log in as root. Now, okay, add the GPG key first. Now it might seem kind of silly that I just copy paste those commands. I'm trying to show you how to do this manually. So we add the source to our list of sources, and I'm gonna do update, and then install Condor. Alright, apt install Condor. This installation, it's very talkative. It really asks a lot of questions. When installing with an automated script, you have to make sure that it doesn't ask any questions, otherwise it'll just get stuck. Now before we can run HTCondor, we will need to create a configuration file. And for now I will just quickly copy paste it. Basically it defines what is your main host computer, which will control everything. It's called negotiator, and then some firewall rules and everything. We don't care about firewall right now. Also, you might have noticed that the address I put in has a really weird domain, .eternal. It's a virtual cloud network, where all Google instances, they're interconnected on their own virtual network, and they have their own addresses here. I could just type in master, it will still work, and save and exit. And finally, I'm gonna start this. I'm not sure about the terminology. As a service, I think in Windows they're called services. And Condor status. Alright, so what it shows us right now, we have one machine here. It's called master. In the unclaimed state, means that it's free, ready to go. It shows what memory it has, and also there's a list of that shows that in total we do have one machine. Now we are going to set up a cluster, but let's just try to run something on this one. But first we need the files to run. Alright, so to copy our executable to the remote machine, Gcloud Compute SCP secure copy, we will need to copy primes and another file that I call SP, and it will go to master, but here I'll need to put the path where the files will go. Now the files are copied, compute SSH master, and we're back in the remote machine. Now we have two files, primes, which is our executable. I can check if it still runs totally fine, but the goal is to run it on the cluster. So there is a small script that goes like this. It'll give it as an argument 200,000. All the output will be collected into the file, the process number dot text, and I will put 10 instances. Condor submit SP Condor status. Alright. Alright, so what the status shows is that one node is currently claimed and actively running our code. There is 10 output files already created, but 9 of them are empty, and one is already populated with the following line. It says, this machine calculated all 17,000 prime numbers under 200,000 in 5.8 seconds. Now if I refresh my list, they're all computed now, and the job cur should be empty, and the machine, the node, is again unclaimed. Alright, so the goal now is to run is to create a larger cluster. Essentially, it's the same process. The only difference right now is that I will use a script to create those, a script that I prepared earlier. It does exactly the same steps with a tiny bit of a modification. So first, the difference in comparing with the previous script is the role of the node. We will only have, instead of having all this negotiator and scheduler, the only components of Condor that will be running is master and start D. And also I have to make sure that I have the right address for my Condor host. Now this address is on the virtual private cloud network that connects Google's instances. And let's run create. Hopefully once the machine is initialized, it will run that script, and instead of setting up everything manually, it'll just make it automatically. So Gcloud Compute SSH ND1 Condor status. Alright, so at the moment we are running Condor, but it did not detect the new node just yet. We will also log into the master Condor status, and it shows us that 2 nodes are available, and the node itself. So we can only submit the task from the master node. The other one, which is called node 1 right now, it will only be used for actual computing, but you cannot submit the job from there. Now I can repeat the process. I can submit my task. It's submitted to the cluster, and now I have both machines reclaimed and they're processing. Obviously it will go about twice as fast now, and that's it. So you can keep adding those nodes. There is a way to do this even more automatically. For example, you can create an instance group, which is sort of a managed group of instances. All you gotta do is just put how many of those you want. With Google, the free version of the Google Cloud Platform, it will only allow you to run 8 CPUs in the same zone and 12 CPUs maximum. So you can have, for example, 8 in North America Northeast, which is Montreal, and you can have 4 additional ones in another zone, for example in Iowa. They will still all connect into the same cluster because they're on the same virtual private network, as long as you put the full address of your main node. They will all know how to connect to that and pull the data accordingly. So this concludes the video for now.